In this video, I will review the problems that were presented as examples in the reading summary so that you can check your work. So for the first problem that you had in the reading summary was to complete the following statements with the correct number. So how many outcomes are possible if two coins are flipped? Well, the coin, if you have two outcomes, you have heads and tails, so that's 2. And if two coins are flipped, you're going to have 2 times that number, so you're going to have a total of 4. For how many outcomes are possible if two 6-sided dice are rolled? So a 6-sided die has 6 outcomes, 1 through 6, and you're going to have 2 of them. There are basically 6 of them. 6 times 6, which is 36. And that's because each number from one could be combined with each number from the other one. So you have 6 times 6 in total. How many possible outcomes are there if one 6-sided die is rolled and one coin is tossed? So you have 2 possible outcomes for the coin, 6 for the dice, so you're going to have 2 times 6, which is 12. How many outcomes are possible if 3 coins are tossed? So you're going to have 2 for each coin toss, and so you have 3 coins, which would be 2 cubed, which is 8. For 4 coins, it would be 2 to the 4th power, or 16. For 10 coins, it's going to be 2 to the 10th power, which is 1024. And so, that's what those are going to be. For the next one that you were asked to do, a box contains 3 cards. On one card, there is a sun. On another card, there is a question mark. And on the third card, there is an apple. 2 cards are being selected at random with replacement. That's an important concept right there, with replacement, because if it wasn't with replacement, that would change how we would, calculate the various outcomes. Round any probabilities of 4 decimal places if needed. So determine the number of sample points in the sample space is the first thing they ask you to do. So basically, my first draw, I could have a sun, a question mark, or an apple. And each one of these, I could have the same 3. So basically, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 different outcomes. Determine the probability that 2 cards containing apples are selected. So this represents the first draw. This represents the second draw. So basically, for this to happen, I have to go down this path of having the first one be an apple and then having the second one be an apple as well. That's one path out of 9. So that's a 1 out of 9 probability, which is 0.1111 approximately, with 4 decimal places. Determine the probability that a card containing a sun and then a card containing a question mark are selected. So it's very specific. A sun, and then a question mark. So again, I have to go down this path here, which is 1 path out of the 9 I have. So it's still 1/9, which is still 0.1 repeating. Now this one's a little bit different. Determine the probability that a card containing a sun and a card containing a question mark are selected. So it's not saying which order they are. They both have to be selected, but any order. So basically, I could have this path here again, or I could have this path here, which gives me 2 paths out of 9 I could follow, which is 0.2 repeating, or 0.2222 for 4 decimal places. Determine the probability that a card containing a sun or a card containing a question mark are selected. So I only need to have one or the other. If I have both, great. And so which one of these satisfies these conditions? Which one of the pathways? Well, these are all the pathways. So this one satisfies that condition. It has both suns, but I have a sun or a question mark. That's, it satisfies it. This one as well. This one as well, because it has a sun. It has an apple, but, since the sun was selected, it's still considered to be one of these options. If the question mark this has both, so that's good. 2 question marks works fine. A question mark and an apple works fine because at least it has the question mark. For the apple one, this one works fine because it has at least the sun. This one works fine because it has the question mark. The only one that doesn't fit having a question mark or the sun is the pathway that goes from apple to apple. So basically, 8 out of the 9 fit this situation here, which is 0.88. It's actually 0.8 repeating, but it's 0.8889. How do these differ if I don't have replacement, which is how we normally would pick cards from a deck or something like that? So now we're looking at the same questions without replacement. So determine the number of sample points in the sample space. So on the first draw, I could have the sun, I could have the question mark, or I could have the apple. Now what happens after that depends upon what was drawn the first time. For the sun, I could either get the question mark or the apple on the second one. For the question mark, I either get the sun or the apple on the second draw. And if I drew the apple first, I'm either going to get the sun or the question mark on the second draw. So that's 1, 2, 3, 4, 5, 6 different pathways. Which means the next one, determine the probability that 2 cards containing apples are selected. Well, since I'm not replacing it, if I draw an apple on the first time, I'm not going to be able to draw an apple on the second time. For me to draw an apple on the second time, I would have to draw on something else on the first time. So there is no pathway that produces 2 apples. So that's the probability. Determine the probability that a card containing a sun and then a card containing a question mark are selected. So that's going to be one pathway, but now it's one pathway out of 6, which is about 0.1667. It's actually 0.1 and then repeating 6s, but rounding it to 4 decimal places. The probability of containing a sun and a card containing a question mark. So I have to have both. So this one works, and so does this one. And that's going to be 2 out of 6, which is the same thing as 1/3, or 0.3 repeating, or 0.3333 for our purposes. For the last one, determine the probability that a card containing a sun or a card containing a question mark are selected. So if it contains both, great. So this pathway works, 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 and so does this one. And so basically every pathway has at least, a sun or a question mark as one of the cards, which makes sense because even if I don't draw it on the first draw, I'm going to have to draw one of them on the second draw. So basically 6 out of 6 or 1 is the probability for that happening. 3 coins are tossed. Determine the probabilities below, round to 4 decimal places if needed. Different ways of doing this, but since it is just 3 coins being tossed, you can come up with all of the possible outcomes just by listing them. So I have 3 heads. These are all the ones that have 2 heads. All of these have 1 head, and this one has no heads, or all tails. So I have basically 8 different outcomes. See, that's 3 heads and no tails. That's 2 heads and 1 tail, 1 head and 2 tails, no heads and 3 tails. So the probability that no heads are tossed. So out of the 8, there's only 1 of those. So it's going to be a 1 out of 8. 8 outcomes, 1 out of 8, which is 0.125. The probability that at least 1 heads is tossed. So that means 1 head or more. That's 7. These 7 outcomes here, this one and up has, at least 1 head, and it has 1 or more, basically. And that's 0.875. The probability that exactly 1 heads is tossed. Exactly 1 heads are these 3 here. So 3 out of 8, which is 0.375. The probability that 3 heads are tossed. Well, that's this case up here. It's only one case where I have, out of the 8, that I have 3 heads. That's a 1 out of 8 again, which is 0.125. 2 fair 6-sided die are rolled. Determine the probabilities below, round to 4 decimal places if needed. Dice tossing is one of the ones that usually comes up a lot in any probability course, which is usually why one of the tables that students tend to remember a lot are the possibilities for dice. So basically I'm going to come up with the outcomes here, the dice pairing. So I could dice totals could be 2 through 12. 2 is when I have 2 1s being rolled. A 3, I can have the first die being a 1, the second one being a 2, or vice versa. 4, I can have a 1 and 3, a 2 and 2, or a 3 and 1. And I keep adding these together, keep making this chart. 7 is the one that has the most probabilities. 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. When I get to 8, I have, basically 2 and 6. I can't do 1 and 7. There's no 7 on the 6-sided die. So 2 and 6, 3 and 5, 4, 4, 5 and 3, 6 and 2, 9, and it goes all the way back down again until I get to 12, where the only option I have there is 6 and 6. So it asks for the probability of rolling a double. Well, first I put these numbers down here. So basically there's, one outcome of getting a 2, 2 outcomes of getting a 3, 4 outcomes of getting a 3, 3 outcomes of getting a 4, 4 outcomes of getting a 5, so forth and so on. So the first one has the probability of rolling a double. Doubles means that both the dice are the same. So that means I'm going to have a 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6. That's 6 out of the 36 possibilities I have down here. So that's a 6 out of 36, which is a 1/6, which is 0.1667. Probably the sum of 8 is rolled. Well, here's 8, and there's 5 outcomes where I can roll an 8. So that's going to be a 5 out of 36. And 5 out of 36 is about 0.1389. Probably the sum of 2 is rolled. There's only one probability out of that, 1 out of 36. And that's 0.0278 when rounded to 4 decimal places. The probability of the sum rolled is even. So I'm only going to count the 2, the 4, the 6, the 8, the 10, the 12. So I'm adding the 1, the 3, the 5, the 5, the 3, and the 1. That's 18 out of 36, which is 1/2, which is 0.5. And the probability that at least 1 3 is rolled. So I got to try to find out which one of these has a 3 in it, or more of 3s, multiple 3s. So, I'm going to try to count, these are all the ones that has 3 rolled at least once in it. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 out of 36, which is about 0.3056. A bag has 3 black marbles, 4 red marbles, and 5 white marbles. Chris will choose 3 marbles from the bag with replacement. So basically, he picks a marble, looks at the color, puts it back in the bag, mixes it up, and then picks again. Determine the correct probabilities below, round to 4 decimal places if needed. So again, I'm going to kind of try to map out what's going on with this. I mean, there's shortcuts that you eventually do learn, and we do learn a couple of them in this course as we get to some of the later lessons. However, we're not going to get too far into this. So a lot of it, the way this book is approaching it, they want you to map it out. So here's what I can possibly have happen. The first draw, I pull a black, or a red, or a white. Now I'm not going with numbers here. Okay, I'm just going with what are the possible outcomes. On the second draw, I could pull a black, a red, or a white, and I could do the same thing on the third draw. So, what's the probability of choosing at least 1 red marble? 3 out of the 12 are black, 4 out of the 12 are red, 5 out of the 12 are white. One of the easiest ways to take care of this situation here is to do the probability of Chris choosing at least 1 red marble, is to realize that at least 1 is the exact opposite of none. So the probability of none or red is pretty easy to come up with, because if I'm doing replacement, there's 4 red marbles out of the 12, which means that 7 out of, 4 out of 12 is red, so 8 out of the 12 are actually not red. So basically, it's going to be 1 minus 8 12s times 8 12s times 8 12s, because each time I draw one, I have an 8 out of 12 chance of pulling not a red. And so that's going to be 8 27ths, which ends up being 1 minus that, which is 19 27ths, which is about 0.7037. So that's the probability of it choosing at least 1 red marble. what is the probability of Chris choosing at least one black marble? Well, none are black. It's the exact opposite. So if I do 1 minus none being black. Now, black, there's 3 of them, so there's 9 that are not black. So 1 minus 9 twelfths times 9 twelfths times 9 twelfths, which comes out to be about 37 out of 64, which is about 0.5781. I do expect it to be a little lower because there's less black marbles in there. If I did the same thing for at least one white marble, then I would have that. Now, here comes the tricky part. Probably of at least 2 white marbles. This one's a little bit more problematic because, what's the exact opposite of that? So here's why I have to kind of look at, possible scenarios here. This is where this thing down here is coming into play. I could do a black, white, white. I could do a red, white, white. I could do a white, black, white. I could do a white, red, white. Or I could do a white, white, black. Or I could have a white, white, red. Or I could have all 3 being white. These are the outcome situations where I have 2 or more white marbles. What I got to do is figure out what the probability of each one of these is. So I'm looking for the probabilities of these various outcomes, these specific outcomes. And that's why I needed that chart down there for that one. For the first two, I really didn't need it because, if I'm not replacing, I know it's an 8 out of 12 chance of not getting a red. I know it's a 9 out of 12 chance of not getting a black. I can figure out what the probabilities of each one of those cases are, do 1 minus that, no sweat. Here, I'm just going to find the probability. These are all the situations where I have 2 or more white marbles. And so this probability is going to be 3 twelfths times 5 twelfths times 5 twelfths, which gives me this. And I calculate each one of these. I'm just taking the probabilities that are from over here and putting them in and multiplying them through. And then eventually just going to add them together. So I add all these together, I get 325 out of 864, which is about 0.3762. So that's the probabilities of those. Now, in the next instance, we're going to do this without replacement. So exact same situation. On the first draw, these are what the probabilities are, but what happens on the second draw gets a little bit more problematic. We're not replacing it. We're not putting the marble back after we look at it. So it's still easiest to do the probability of at least 1 red marble whenever I have, by doing 1 minus the probability that none are red. Now, I know on the first draw, I'm going to have 8 out of 12 not being red. Assuming that's the case, the next one I'm going to have 7 out of 11 not being red, and then I'm going to have 6 out of 10 not being red. And so that's where I get these probabilities. That's really the only difference I'm going to have with this, is because of the fact that, I'm not going to have 12 marbles to choose from if the first one's not red. I mean, all 3 of them have to not be red. So the first one's not red, it's an 8 out of 12. Now, assuming that happened, the next one's going to be a 7 out of 11 and a 6 out of 10. I do 1 minus that, I get 41 out of 55, which is about 0.7455. The probability of choosing at least 1 black marble. That's the 1 minus probability that none are black. And 9 out of 12 are not black in the first draw. So I'm going to have 1 minus 9 out of 12, and then 8 out of 11, and then 7 out of 10, which gives me eventually a 34 out of 55 shot, which is 0.6182. Now, with at least 2, I don't have the exact opposite effect here. I still have to kind of go with, what we did before. All these probabilities. And so I'm still going to do them, but how I'm going to calculate them is going to be a little bit different, because the probability of getting a black on the first draw is a 3 out of 12. And then I'm going to have a white on the second one. That's going to be a 5 out of 11. I still have 5 white marbles, but there's only 11 marbles to choose from. And in the second one, the third draw, I'm going to have 4 white marbles left, and I have 10 marbles overall left. And I keep on doing these probabilities in a very similar fashion. 4 out of 12 for being a red, 5 out of 11, 4 out of 10. White here would be a 5 out of 12, times a 3 out of 11, times a 4 out of 10, so forth and so on down the line. And then again, I'm just going to eventually add these probabilities together. And I get a 4 out of 11 chance, which is a 0.3636 probability. So make sure you're always paying attention to with replacement or without replacement, because there are adjustments that have to be made for those cases. Without replacement is usually assumed to be the case, because that's how we normally would draw marbles or cards or what have you, or choosing people for that matter. I mean, I'm not going to say if I'm going to choose 5 people out of 20, I'm not going to choose the same person 5 times. So without replacement is always assumed to be the case anyway, unless you're told otherwise. But if you're told there is a replacement, make sure you're handling it appropriately, and if you know there's not a replacement, make sure you're handling it appropriately. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.